Hi girls, we're going to do the conservation of momentum question now, and it's all about a target shooter aims and fires a 5 kilogram rifle at a stationary target. A small explosion in the barrel of the gun fires a 4-gram bullet out of the barrel at 500 meters per second. So what we've got here is the barrel of the gun with the bullet inside. Okay, and they're considered to be one system. So we find the momentum of the bullet plus the momentum of the gun. Okay, so the bullet is 0.004 of a kilogram and it's going at 0 meters per second, plus the mass of the gun, which is 5 kilograms, also going at 0 meters per second. So the initial momentum obviously is 0 kilograms meters per second. Okay, so that's the initial momentum of the rifle and the bullet before the rifle is fired. So there's your answer to A. B is asking what is the momentum of the bullet after the explosion. So in part B we only have the bullet to consider, and its mass is 0.004 kilogram, remembering that we need to use SI unit, and it leaves the gun at 500 meters per second. So the momentum of the bullet once it's left the gun is 0.004 times 500, which actually gives us 2 kilogram meter per second. So that's your answer to B. Now, if as the bullet leaves the gun, for part C, the bullet's going this way at 500 meters per second, and the barrel of the gun will recoil this way. So that's what recoil is. Okay, as the barrel of the gun moves back this way. So what we have to do is calculate that velocity. And the things that we know is, the assumption that we make is that momentum is conserved. Momentum is conserved. So if the momentum of the bullet when it's left the gun is 2 kilogram meters per second, then the momentum of the barrel must be negative 2 kilogram meters per second. That's because we know that we had an initial momentum of 0. So we know this because the initial momentum must equal final momentum. So 0 must equal 2 minus 2. That's how you get to 0. So that there must be the momentum of the barrel of the gun. Okay, so I'll carry on the next page with that. So we know that the momentum of the barrel must be negative 2. Now we've got to find the velocity. So momentum of the barrel is minus 2. The mass of the barrel, we'll just use the whole gun, is 5 kilograms. And we need to find the velocity. So we know that momentum is mass times velocity. So the velocity is going to be the momentum divided by the mass, which is negative 2 divided by 5. So the velocity is minus 0.4 meters per second, or 0.4 meters per second to the left or backwards. Yeah. Good. Okay, part D is asking us, alright, so now we have a target and we've got the bullet coming towards the target. Okay, so what's going to happen is that the bullet is going in this direction. The target initially is stationary, and then when the bullet hits the target is going to go back as well. Okay, so to find that out, the total momentum of the bullet and the target will be the momentum of the bullet. I'm just going to flick back a page so that we can work out what that is 2 kilogram meters per second. The target, the momentum of the target is 0 kilogram meters per second, and that's because it's stationary. So the momentum of the bullet plus the target has to be 2 kilogram meters per second. That's the answer to D. And finally, our answer to E. What velocity do the bullet and the target move after they collide? Okay, so we know that the momentum of bullet plus target is 2 kilogram meters per second, and when the bullet lodges into the target, the mass of the bullet plus target is 0.004 plus the 0.5 kilograms of the target, which you're given in the question, so that's 0.504 kilograms. And we also know that momentum is mass times velocity, so if we want the velocity, it's momentum over mass. So let's work that out over here. V is 2 divided by 0.504, which gives us 3.997, or 4 meters per second to the right. Okay, hope you followed that, girls. Good luck with doing that by yourself now.